All right, let's talk about distance and midpoint formula. Distance and midpoint formula. Right, distance and midpoint formula. So we are studying a new chapter, new concept in algebra, and we're going to start with the distance and midpoint formula. Now, before we get into the distance and midpoint actual formula, let's talk about the coordinate system. So the first coordinate system is rectangular coordinate system. Well, even before that, it all start with this point. Let's say we have this point right there, right? Let's say we have this point. Now, can you identify the exact location of this point? Can someone identify the exact location? Well, you can probably say, oh, it's probably right about in the middle, a little bit above, and a little bit towards the left side from the middle, right? If this is the middle right here, a little bit left, a little bit above from the middle. Well, that's generally correct, but that's not precise. That's not precise. So, 17th century mathematician and philosopher, French mathematician and philosopher René Descartes actually came up with this idea. He said, why don't we divide any flat space using these two lines? Using these two lines. So this one line goes like that, another one goes like that, and let's name this line as x-axis. And let's name this line as y-axis. Right, using that x and y-axis, now we can divide this like that. And let's say this is 1, 2, 3. So this is 1, 2, 3, 4, 5. This is 1, 2, 3. And of course, if it goes right in the middle, that's going to be 0. If it goes to the left, that's going to be -1, -2. If you go down, that's going to be -1, -2, and you get the idea, right? So once we divide this any space into with these two lines, now we can identify the exact location of this point using this x value of that point and the y value of that point. So what's the x value? Well, it's right above 4, and y value is 1, right? So this is the x value, this is the y value. This x and y pair, what do we call that pair? We call that pair as ordered pair. Ordered pair. That's the name of this x and y combination. And this has been developed in 17th century, right? 17th century. So a couple of 100 years ago, this guy in France, he's actually a great philosopher. He came up with this idea. Well, in order to identify the exact location, and we need to divide into 4 pieces. And this coordinate system is called rectangular coordinate system. Rectangular coordinate system. I mean, you can. It's not that difficult to guess why this is called rectangular, because you identify any point with this rectangular shape. Now this is called rectangular coordinate system, or a little bit fancier way, this is also called Cartesian coordinate system. Cartesian coordinate system. Well, Descartes' name in Latin or Greek with Cartesian. It sounds similar to Cartesian. So that's why we call this Cartesian coordinate system. So if you want to be a little bit fancier, you can say this is Cartesian coordinate system. If you're talking to your friend, then you should say, oh, this is rectangular coordinate system, right? All right. Now let's talk a little bit more about this coordinate system though. So we have this one line goes like that, another line goes like that. This is x-axis, this is y-axis. We have 0 right in the middle, 0 right in the middle. So this side is called the first quadrant. I'm going to go counterclockwise. And so this side is going to be the second quadrant. This is third. This is fourth quadrant. Now, as you can see, any point in the first quadrant, x is going to be, remember this is the positive side, greater than 0. Y is going to be greater than 0 because it's up is positive. Now, what about this one here? If there's any point on this side, second quadrant, x must be, from here to the left is a negative, so x must be negative. Y is still positive because it's up there. What about here? Well, x must be negative. Y also must be negative. What about fourth quadrant? Well, x, this side, is positive, yet y is negative. Right? So it's just a general x and y location, the sign of x and y for these 4 different quadrants, right? 4 different quadrants. So next, before we get into actual distance formula, let me explain why they have that formula. So let's say you have these 2 points. So we have to have this coordinate system first. Let's say we have this x and y. And let's say we have this point at 1, 2, come on. 1, 2, 3, 4, 5, 6. Let's say 6. 3, 4, 5, 6. And of course it goes on, right? And you have 1, 2, 3, 4, 5. And this is 0, right? 1, 2, 3, 4, 5. Now you have this one point right here. And let's say you have another point right about here. Right about here. So this point is right above 1 and 1. And this point is right above 6. And y value is 4. So what they are trying to do is try to figure out this distance between these 2 points. Distance between these 2 points. So before we actually try to figure out that distance, we need to know one more formula or theorems, whatever that you want to call it, Pythagorean theorem. So Pythagorean theorem. So what's Pythagorean theorems? So almost like a side note. So Pythagorean theorem. Oh, I think that's EAN. All right, Pythagorean theorem. So this one of ancient Greek mathematician named Pythagoras said when you have right triangle, the triangle must be, okay, let me draw a proper right triangle. Okay, that's better. So that right triangle, meaning that angle right there must be 90 degree. It must be 90 degree. And let's say this side, the length of this side is A, length of this side is B, length of this side is C. If you have these ABC lengths, the relation between A, B, and C is like this. A squared equal B squared plus C squared. Now, technically speaking, Pythagoras is not the one who actually came up with this idea. This type of relation, in right triangle was found in at least 3 different ancient culture. It was found in ancient Chinese, ancient Peru, and ancient Egyptian, right? Way before Pythagoras, in a way, published this. But he's the one who had a lot of students, and he's actually a very strange guy because he called his student as disciple. He was almost like a cult leader in a way. There's very interesting stories like his students and doing something really bad for his teacher and all that, but we're not going to get into that. So anyway, this formula, this theorem is known as Pythagorean theorem, right? Pythagorean theorem. And it's, if you really think about this is pretty interesting, theorems. How do they came up with this idea? Can you prove it? Well, yes you can, which we are not going to do, but if you are interested, you can Google up proof for Pythagorean theorem in Google, then they'll give you all kinds of different style of proof. And if you take geometry course, then they'll also deal with, the course also will deal with this Pythagorean theorem, right? Anyway, we are going to just use this theorem to identify the distance between any given 2 points. So you can see that we also have this triangle, and we have this right triangle right there, right triangle. So what we need to know is this distance. Let's call this for D for distance, and this, we need to figure out the length of this side. We need to figure out length of that side. Well, length of this side from 2 to 6, 1, 2, 3, 4, so that must be 4. Or you can also do 6 minus 2, 6 minus 2, that's equal 4, 2. What about here? From 1 goes up to 4, so it's 1, 2, 3. So it must be 3. But it actually came from 4 minus 1. 4 minus 1. Just like that. So that distance, according to Pythagorean theorem, square must be equal to, it doesn't matter which side, let's say this and this, 3 square plus 4 square. Okay, so if I rewrite this, d square equal 3 square is 9 plus 4 square 16, so d square is what? D square 25. So how do we get rid of this square there? Remember in our previous chapter we talked about the square root technique in quadratic equation. Well, we're going to do the same thing. We're going to take the square root on both sides. Technically speaking, when we take square root on both sides, we're supposed to have plus minus there, but we don't have to worry about the minus because we are dealing with distance. You can have a negative distance, right? At least in this setting. So square root and square cancels out. So you have d equal square root of 25, which is same thing as square root of 5, right? 25 is 5 square. So again, this cancels too. So it came up with a 5. So d must be equal to 5. Right? So there we have it. This distance right here turns out to be 5. So we're going to use the same idea to make it a general case. So let me redraw it. Okay, so let's say we have these 2 points. And what we need to find is this distance, right, between these two. So the x value of this point is going to be x1 right here, and right here is going to be x2. Now what about the y value? Value of that point is going to be y1, and that point right there is going to be y2. So you know, this point right here, what will be the order pair for this point right here? What's the x value? x1. What's the y value? y1. That's this point right there. What about this point? Well, what's the x value? x2. What about y value? y2. So that's this point right there. So we are trying to figure out the distance from here to here. Now we need to find distance of this line and this line. So what would be the distance from here to here? Well, x2 minus x1. I mean, that's what we did right here, right? It was 6 and 2. So we did 6 minus 2 became 4. And we did the same thing for y, right? Y. So this distance must be x2 minus x1, right? x2 minus x1. What about this distance? This distance is going to be y2 minus y1. And d is the one that we are after. So, you know, according to the Pythagorean theorem, what was the deal? Let's say we have this, and this. So the deal was d squared must be equal to x2 minus x1 squared plus y2 minus y1 squared, right? So how do we get rid of this square thing? Well, we take the square root on both sides. Then this cancels out. Then we came up with d equal square root of x2 minus x1 squared plus y2 minus y1 squared. And that is what we call the distance formula. Distance formula for what? Distance between 2 points. Namely x1, y1, and x2, y2. These two formula. So, I mean, do we need to memorize it? What do you think? Take a wild guess. Do we need to memorize it? Answer is yes. I would definitely encourage you strongly to memorize this formula. I mean, can you drive it just like I did? If you know the Pythagorean theorem, can you drive it like that? Can you actually come up with this formula? Yes, you can. But I wouldn't recommend that when you're doing homework and when you're doing exam, right? You wouldn't want to drive it. You want to memorize it and just apply it, right? So let's do an example. Remember, half of mathematics is based on memory, right? Half of mathematics is based on memory. I want you to memorize this formula. Find the distance between distance, say D, between, let me give it to a point, -5, -4 and 5, and 3 and 2. All right, 3 and 2. So whenever that we are doing something like this, I want you to write what's x1, what's y1, and things like that. So I'm gonna write, this is my x1, this is my y1, this is my x2, this is my y2. Just to avoid any confusion. And all we need to do, put that number in that formula. That's it, right? So D equal square root of x2 minus x1 -4 plus square plus y2 minus y1 square. All right, equal, let's simplify. That's 3, this double negative become plus, so 3 plus 4, so that should be 7 square plus, that's what, -3 square, right? -3 square. And that would be 7 times 7, 49, plus -3, 9. So that's what? That's square root of 58. And that's a fine answer by me. You don't have to put it in the calculator and get the estimated value, right? This would be the better answer for me anyway, right? All right, so there we have it. This is the distance formula, right? Distance formula. Okay, now see if we have enough space. All right, let's do one more example. And this is very typical type of example. So, example, consider the 3-point point A is -2 and 1, point B is 2 and 3, and point C is 3 and 1. Now, the question is, verify that the triangle formed by those points is a right triangle. Right? We need to show that triangle that we have by these 3 points is going to be the right triangle. I mean, even though they don't ask us to graph it, I think it's a good idea to actually graph these 3 points. You know, just have some general idea. So let's see. Yep, like that. A little bit better. So on -2, say 1, 2, 3. 3, that's 0, and goes up to 1, 2, 3. You know, so point A, -2 and 1. That's our point A. Point B, 2 and 3. That's our 2 there, right? 2 and 3. That's our point B. Point C, 3 and 1. That's our C. So if we connect those 3 points, it looks like our triangle looks like this. Right? Don't like that line. Let me draw it again. Okay, that's better. Okay, so this line right there. So it looks like this is right triangle, right? And that's what we need to verify. So what do we need to do? Well, we need to show that this distance, which is the longest distance, square is same as this distance square and that distance square. So we need to show distance between AC square equal to distance between AB square plus distance between BC, slightly move to this side, square, right? If we can show this, then we can prove, we can verify that this actually forms a right triangle. So that's a lot of calculation, but remember, this is just basically adding, subtracting, and multiplying, not even dividing, right? I mean, how hard can it be? So let's find distance between A and C, right? A and C. Well, what are those points? Those points are right there. So let me actually write down the point -2 and 1. This is 3 and 1. This is 2 and 3. So between A and C, it's going to be square root of x2 minus x1. So 3 minus -1 square. No, it's -2. Sorry about this. This is x2. This is x1. So 3 minus -2 square plus y2 minus y1 which is 1 square. So what would that be? That would be square root of, this is cancel to be plus, 5 square, 25 square, nothing. I mean, this is 0 square, nothing. So square root of 25, that's 5, right? Okay. What about distance between now A and B? Let's go for this distance, A and B. So that must be 2 minus x1 negative 2 square plus y2 3 minus 1 square. Okay, so what would this be? This be square root of, this would be cancel to be 2 plus 2, which is 4 square, 16, plus this is 2 square, 4. So this would be square root of 20. Now we're going to do BC, right? Distance between B and C. Okay, so this would be square root of, can't really see, right? Okay, square root of point B. So x2 3 minus x1 2 square plus y2 minus y1 3 square. Okay, so what would this be? This would be 1 square, which is 1, plus this is negative 2 square, which is 4, which is square root of 5. So there we have it. The distance between A and C square equals distance between A and B square plus distance between B and C square. We just verified it because what's this? This is 5 square, which is 25. What about this? Distance between A and B square. That's square root of 20 square. So that's 20. What about this? That's distance between B and C square. That's 5. So 25 equal 20 plus 5. Verified. Therefore, this A, B, and C will form right triangle. Right triangle. All right. Now let's move on to the midpoint. Midpoint is easy, right? Easy. So midpoint between x1, y1, x2, y2, right? Okay, so midpoint that we're going to call M of these two, the x value and the y value is going to be x value is going to be x1 plus x2 over 2. Y value is going to be y1 plus y2 over 2. Just like that. So what does that really mean? That means, you just add these two x value and divide by 2 to find the half. I mean, that kind of makes sense, right? And you add these two y value and divide by 2. So that's the midpoint formula. I mean, how hard can it be? How hard can it be? So let's do one example. Find midpoint between, let's say, -5 and 5 and 3 and 1. So the midpoint is going to be, remember, this is x1. Well, change the color. This one is x1, y1. This is x2, y2. So x1 -5 plus 3 over 2, right? That's x value. And y1 5 plus 1 over 2, that's y value, right? Which is what? This is -2, right? -5, -3, -2 over 2, which is -1. What about this? This is 6 over 2, which is 3. And that's our answer right there. I mean, how hard can it be? Right? Easy. So that's the look at this writing. Between, I guess I was anxious to fit this in this video, right? Between. Anyway, so midpoint is compared to distance formula is very easy, right? Very easy. And I actually never made this midpoint as one of my exam questions because it's just a little too easy. But you never know, right? I might change my mind. So midpoint is just adding those two x divided by 2, adding those two y divided by 2. Okay.